So I'm going to show you what I have on my character blueprint before I can start the tutorial. So what do I have on my character blueprint? Well, I have the event tick with nothing here. I'm going to be adding the code soon. I have left some comments here, so it's going to be better for me to organize things better. You don't need to worry about this. This is the sprint. This is the jump input. And I have all the default code. You don't need to worry about them. Here on the animation blueprint, what I have some variables that I'm going to delete right now because I'm going to start from scratch. So I have the default locomotion system, nothing much. This is the event graph. There's nothing here. So let's start the tutorial. So how are we going to do this? Basically, we're going to have keys for the character to jump, for jumping between walls. And here, if we are walking, then if we jump and aim for the right, then we're going to place a line trace that is going to be from here to here. So this line trace is going to be placed horizontally from the pelvis to the right side. So this line trace is going to make the character detect walls. And if we are jumping, if we jump to the left, then this trace detection, it's going to be, we're going to modify the values that changes how the line trace is positioned. And we're going to start positioning the line trace for going to the left. So this is going to detect the left wall sides. So this is going to make us to detect different walls and different angles. So for starting on the event tick, we are going to get a branch. And first, we need to get a variable called enable trace wall right. So if the value of this boolean is true, then we can detect walls, right? We're going to make the line trace detection, the calculation for it. So we're going to get the line trace for objects. And now we're going to do the math for placing that line trace. But before that, we're going to promote object types to a variable. Now we're going to select here on the draw debug type, we're going to select for duration or for one frame. I think it's better for us. Then we're going to promote it to a variable and just let it there. Compile. Here on object types, we're going to add a new element and let it word static. So it's going to identify word static meshes in our world. Now we're going to do the math for placing the line trace. We're going to first get the actor current location. We're going to get actor right vector. We're going to multiply it. We're going to create a new float. This is going to be called trace direction. It's going to be a float. And we're going to connect this float to here. There we go. And now we're going to add this value to here. And now we're going to connect this to here and connect this to there. I'm going to collapse this to a node and say, I don't know, math for the line trace. Now we're going to choose how further the line trace is going to go from the left to the right sides. If we choose the trace direction to be 90, then let's see how that goes. Let's hit on play. And as you can see, let me just remove this dummies here. All right, if you press on play here, as you can see, there is a red line. And this red line is pointing towards the right direction. I chose 90 because it's a good value for detecting walls on my right side. If I want this line trace to detect the left side, then we're going to change positive 90 to negative 90. I'm going to set the default value to be 0. I'm going to unpin this. I'm going to break hit result, collapse this to a node. It's easier for me. I'm going to call this result. And I'm going to get the normal of the wall. Out of the normal, we're going to get the rotation from X vector. And out of here, I'm going to break rotator. And I'm going to get the Z value. I'm going to add here. I'm going to get the trace direction. Plug that in. And here on outputs, I'm going to pin this here and pin the normal there. And we're going to use the Z yaw value here we're going to use this value for rotating the character in the right side, in the right direction, when we are attached to the wall. So out of here, I'm going to promote it to a variable. Just gonna call it normal. And I'm also going to promote this. This is going to be called fixed character rotation Z wall. Now here I'm going to split the structure pin, because depending on what direction you go, for example, here I'm facing the forward, I'm going forward, and if I touch my character here, my character is going to go forward. But if I'm on the opposite direction and I go here, then I want my character to move forward as well. So to fix bugs related to that, I'm going to get a branch here, and I'm going to know by this branch which direction the player is facing. So for example, if the trace direction is going to be more than 1, then by doing this, we're going to know which direction the player is going for. So here on the X, I'm going to multiply, and I'm going to get the negative value of whatever value is going to be for the X and Y. And we're going to copy this and paste here. I'm going to split them. So it's going to be like this. Now I'm going to get another branch. And this condition is going to be plugged here into return value. Now we want to create a variable that is going to tell if the character can be attached. So I'm going to write can be attached. And this is going to be a boolean. This is going to be true. And I'm going to do once. I want to create a custom event. So I'm going to add custom event. And this custom event is going to be about rotate the character to the right position. And I'm going to set the actual rotation. And I'm going to split it. And I only want to rotate my character on the Z yaw. That means that I'm going to give you an example. So here, if I rotate my character like this, I'm rotating it on the Z axis. You see that this value changes. I think you got it. I'm going to drag and drop the fixed character rotation float here. So whatever value is in here, then we're going to set it. It's going to be executed. So whatever float value is here, then we're going to rotate the character depending on this value here. Now I'm going to rotate character. I'm going to use the event. I'm going to call the event. Now I want to choose a key for making my character to jump between walls. So if the character is already attached, then if we pressed the 1 key, for example, I'm not going to choose the 1 key because it's very dumb. If I can use the mouse button. If you have a gaming mouse, then you have the button that is below it, so you can use that. And I'm going to add this to a sequence, and this one is going to be here for resetting the value, and one for retrievable delay. And now we're going to get a branch. Remember that you have to set this value to be 0.7, and I'm going to drag and drop the can be attached to the condition here. And finally, we're going to create a variable to be for knowing if the character is attached. So I'm going to create a variable like this, and I'm going to set it, duplicate it. True is going to be here. There we go. Now, if you are pressing the D, then we want to set the trace direction to the right side. So it's going to be positive 90. And here, if we are pressing A, then we are moving to the left. Then it's going to be negative 9. It's going to be negative 90. Now we're going to attach the character to the wall if the line trace is detected. But for that, for attaching the character to the wall, I'm going to be pressing the letter, not the letter, the right mouse button. So if the character can be attached, then we're going to attach it. So I'm going to drag and drop the can be attached variable. I'm going to get it to a branch, and I'm going to get actually set character is attached, and I'm going to duplicate this to false. And I'm going to call the event to rotate the character. Now here, event on landed. This is the event that is called when the character touches in the ground. So let's say, for example, the character is jumping and then he falls, he touches the ground, and as soon as he touches the ground, this event, whatever is inside here, is going to be executed. So let's say print string. I want to print hello every time the character touches the ground. So I'm going to jump, and as you can see on the top left corner, I get hello. And this is very useful for, let's say if the character is wall running and then he touches the ground, I want the character to stop wall running. Then I'm going to connect this to here. And then I also want to disable the line trace and disable this as well. All right, compile, save. Now we're going to be setting the impulse when we are attached to the wall running, blah, 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 okay? We want to jump between walls. So I want my character to go from the right wall to the left wall. And for that, we need an impulse, which is going to just push the character to the wall, to the next wall, right? But for that, we need to know, for example, if the character is right here, we want the character to have an impulse to go for the next wall, to jump from the right to the left. But for giving the character the impulse, we need to know which direction the character is, which wall direction the character is facing at, if it's the right or the left one. So if it is the right, then we need the impulse to push the character to the left. If we are on the left side of the wall and we want to jump for the next one, we want the character to be pushed in the direction of the wall that is on his right, right? So for doing that, for detecting which direction the player is facing at, it's very simple. All you need to get is a branch, and here on the trace direction, I'm going to get this value here, and I'm going to plug that to the condition, and I'm going to collapse this all to a macro, and this is going to tell which direction the player is at. Correct. And I'm going to plug that in here. And here on true is going to be place is on the right direction of the wall, and here is on the left. So now we know which direction the player is facing at. So let's get a sequence. Now let's get another sequence that's going to be below. I'm going to get a recheckable delay for both of them. I'm going to add a new variable called impulse forward. It's going to be a float variable. I'm going to set it. So this is going to be we're going to be setting how much impulse you want the character to be launched forward. I'm going to choose 0.4 because it's enough. Now I'm going to create another variable to be, this is going to be called impulse left right. And for the impulse left right, I'm going to add 333. It's a good value for me. And for duration here in the retrievable delay, I'm going to add 0.1. And then after this, we're going to launch the character. The launch velocity Z is how much of impulse the character is going to get upwards, to be launched upwards. I'm going to choose a value of 400, and I'm going to show you really quickly how much impulse the character is going to get with 400. This is the impulse. It looks too much, but on practice, if you want your character to be sticked to the wall, jumping between walls, then the character needs a little bit of force to keep up. Now we're going to do the math for calculating all this. Now we're going to get actor forward vector for launching the character forward. I'm going to collapse this to a node. All right, so this is going to be the math. I'm going to copy and paste this. I'm going to add negative to this. I want to create a variable called rotation. Rotate on detach. I'm going to set it. I'm going to set actor location, actually rotation. I'm going to split it. The reason why I want to rotate my character is because I want to add a little bit of effect. I want to show better to the player that the character is actually going from the right wall to the left wall and vice versa. So I'm going to use this value for that. I'm going to get actual rotation. I'm going to add here. And I'm going to add minus 55. Here is the same thing. But it's going to be positive 55. It's kind of messy, I know, but that's what we have for today. Now, out of launch character, I'm going to play montage. And this montage is going to have an animation notify window on it. So if I go here on more on animations, I've created animation montage out of the wall jump R, which is this animation asset right here. And I have just created an animation montage. You can create yours too. I double click on here, and as you can see, I've created an animation notify window through here. So you can go to animation notify state and go to montage notify window. And you can place it here on the 0.50 milliseconds of the animation. So you can select it here. And the reason why I did it, now we're going the reason why I did this is, holy shit. The reason why I did this is because I want to be able to have an event here on notify begin. I want to execute a branch, and on the condition, I want to know if the character is attached. And if it's false, then I want to disable everything. So I'm going to copy and paste the same here. So if the character is not attached, then we can decide to clear everything. We want to detach the character from the wall. So out of here, I'm going to get the enable wall right. I'm going to set it to true. And yeah, I guess that's it. So for us to activate this line trace for objects here, I'm going to implement some code here on the jump input of the character. So this is the jump function that comes by default. I usually play a sound of the character jumping, but for now I don't need it. For after jump, I'm going to get a branch, and this branch is going to enable the trace. And I'm going to plug this to condition, and I'm going to set enable trace wall right to on if it's not enabled yet. I need to enable this first. Compile. Now our trace line is going to be enabled when we jump. As you can see, it's working. So when I jump, sorry for I don't have the jump animation, but it's fine. When I jump, the line trace is enabled. And when I jump, moving to the right, the line trace is going to be following which direction the player is going. So this code is great. Now, if we want to attach our character, then we can press the right mouse button, and the character is going to face the right direction for the wall. So what I want to modify now is the character behavior when he is already attached to the wall. All right, I'm going to be modifying some movement inputs of the character. Now here on the input, move right, left, I'm going to get a branch out of this. Get a branch, get character is attached. And if the character is attached, I don't want to use this right and left movements. I'm going to copy and paste this. Split the wall direction. And I'm going to get the character movement and set orient rotation to movement. Set use controller desired rotation. Now I want to duplicate this and turn this. Now I can only turn this to true and plug this in here, and now I'll plug this in here. We're going to get the normal of the capsule trace result, and I'm going to split this. I'm going to multiply the y. I'm going to add -1, and I'm going to connect to the wall direction x, and the y is going to go. It's gonna go to the x, and I'm going to add a branch here before everything, and it's going to be the same branch as I have here. And the false is going to be here, and true here. I'm going to compile, save, press play. Now my character should behave like if I press, yeah, this way it's better. I cannot move left or right when I am attached to the wall. That wouldn't make sense. So that's going to be it. That's perfect. And here on the scale value, I'm going to connect the axis value here. Now let's test it out again. Now, if you want your character to be able to move, you know, like this, then you should connect the axis value here. But in my case, I always use the scale value connected, so I prefer it that way. But if you don't want, if you want to try it without, if you want to try the scale value disconnected, like this, you can do it. You can test some things. Now we want to set up our animation blueprint. So first, you need to cast your character blueprint. Pay attention to the name. It has to be the same on here. Well, for you, it might be different, of course, as you have a different character blueprint name. So what you want to do, you're gonna want to type cast to third person character, which is in my case this one here. We're going to cast it. On object, we're going to get the cat player character, and it's going to be here on the event blueprint begin play. If you don't have this, you can type here begin play, as I have here. It's an event. So here I'm going to promote it to a variable, and I'm going to get the execution of this pin here. I'm going to get is valid. Get is valid. I'm going to get the third person character. And here I'm going to get can be attached. Get can be attached. And I'm going to get character is attached. I'm going to get trace direction. And I'm going to promote them all to a variable. Now going to default locomotion, this is what I have. I'm going to separate this and get a blend by bool, blend poses by bool. And this default locomotion is going to be on the false pose. I'm going to create a new state machine. So right click and choose a new state machine. This state machine is going to be named as wall run. And I'm going to connect it to the true pose. And what is going to define which state machine we should use is by the Boolean value called character is attached. If the character is attached, if this condition is true, then it's going to switch to the state machine of the wall run. It's very simple to understand, right? And for the true blend time, we're going to choose the .3 or 0.3. This is how much smooth you want your character to be going from the walk transition or falling transition to the wall run transitions. Basically, kind of like that. All right. I'm going to get my start loop falling. Falling. All right. Jump falling. And I'm going to get start wall run R and the left. And here I'm going to drag trace direction. If the trace is more than 1, then that means that we're going to the right side. And for the left side, we're going to do the opposite. Less or equal than -1. Connect that to there. And there we go. Now I want to get the loop. Not this one, but the wall run. Left, right. We're only going to connect the pins here, and what we're going to do here, if you click on the circle here, you're going to enable the automatic rule based on sequence play, on sequence player in state. So after this animation is played, it's going to play this one here. So I'm going to disable the loop animation, and I'm going to disable here as well. Yeah, I guess that's it. I'm going to compile, save, and I'm going to also do this for this as well. All right. I guess there's not much enough force when we're going to from the left to right or vice versa. So I'm gonna go back to the third person character and see what's wrong here. If we take a look at our code, impulse, this is the impulse forward and this is the impulse left and right. If we change this value, let's say 60, 100, 60, 100 value, let's get a complete value like this. Let's see if it changes much. As you can see, it's better, I guess. But we are going too much forward. We can choose it to be 0.2. Let's see how much difference that makes. Yeah, I guess the launch velocity z is too little, so I'm gonna put a value to be. I'm gonna choose a value of 700, and you can play with these values, see which one works better for you. Let's choose it to be 0.1. Compile save, let's test it out. Yeah, you can play with the values, see which one works better for you, and that's going to be it for the tutorial. I hope you enjoy it, and I see you in the next one. Bye bye.